David here with a question on problem solving with centripetal forces. In this question what we have is a ball hanging from a string from the ceiling, and it's spinning in a circle. The ball has a mass of 1/4 kilogram and is made to rotate at a constant speed v in a horizontal circle with radius of 1/3 meter. The string makes an angle of 30 degrees with vertical. We want to use this information to determine the speed of the rotation of the ball. Well, one thing that jumps right out to me is we're traveling in a circle. And if we're traveling in a circle, then all our centripetal forces and circular motion equations apply. And one circular motion equation that involves speed is the centripetal force. The centripetal force is mv squared on r. Now I know the mass of the ball, and I know the radius of the circle. So if I could just determine the centripetal force on the ball, then I could determine the speed of the ball. So let's take a look at the forces on the ball and see if we can figure out what the centripetal force is. The ball has a mass, so that it has a weight, and the weight pulls it straight down. But it doesn't fall down, it stays level, which means that the tension in the string is supporting the weight. So the full force of the weight, so the same length, has to be supported by the tension in the string, which is always along the length of the string. So the height of the tension has to equal the height of the weight, otherwise the ball would be moving up or down. But because the tension is at an angle, that means that there's a leftover component of the tension, a horizontal component, and it's this horizontal component which supplies the centripetal force. So another thing that I notice is that the centripetal force is the horizontal component of the tension. So now the question comes down to determining the horizontal component of the tension. And that's where things start to get a little bit harder because I don't have much of an indication of what this tension is. The only thing that I know about the tension is that it must be related to the weight. They must have the same heights. So one thing that I know is that the weight has to be equal to the vertical component of the tension, which isn't quite what I want. So I'm going to have to work with that a little bit to make it work. But it is helpful to know because I do know what the weight is. The weight is the mass of the ball times the acceleration due to gravity, and I know both of those things. So I do know the length of this line based on the weight. What I need to do now, though, is I need to find a way to change the vertical component of the tension into a horizontal component of the tension. And we'll do it with a little trigonometry. This is the horizontal component of the tension, Tx, but that means this is 2. You can imagine a little rectangle. The base and the top of the rectangle are the same. And it forms a triangle. And I know a little bit about this triangle because this is a vertical line, and this is a vertical line, and this is the z rule. If this is a 30-degree angle, then so is this. Which means that Ty and Tx are related through tangent. The tangent of 30 degrees is opposite over adjacent. And this allows me to relate Tx and Ty. Ultimately, I want to know what Tx is, so I'll solve this for Tx. Tx equals Ty times the tangent of 30 degrees. And I know what Ty is. Ty is mg. So Tx is equal to mg tangent of 30 degrees. Oopsie. And now I know everything. I know Tx, I know m, I know m and g, and therefore I know Tx, and therefore I know the centripetal force, and therefore I can find my velocity. So let's take this equation down here. We'll start over. Fc, centripetal force, is mv squared on r. But the centripetal force is Tx. So Tx equals mv squared on r. But I know what Tx is. Tx is mg tangent of 30 degrees. This gives me mass on both sides, so they cancel. And it allows me to multiply across by r. I'll also flip the equation around, and I'll say v squared equals rg tangent of 30 degrees. I'll take the square root of both sides. I'll get the square root of rg tangent of 30 degrees. And now my equation is made of only things that I know. I know the radius, 0.33 meters. I know acceleration due to gravity, 9.81 meters per second squared. And I can calculate the tangent of 30 degrees. That can be known. When I punch all this into my calculator, I get 1.4. It is a square root, so I should consider plus or minus. But the question asked for the speed. So the direction is not really important. So I can safely ignore the negative result and just call this 1.4 meters per second.